Hi everyone, my name is Thomas Kim. Today is February 10th, 2021. This is 75th episode about the programming language C++20 standard. In this episode, I will discuss decltype auto, lvalue reference, rvalue reference, and the forwarding reference and the decltype auto. Both forwarding reference and decltype auto are used to recycle rvalue and or xvalue, rvalues and or xvalues. Rvalues, xvalues are represented by rvalue reference. What is common between lvalue reference and rvalue reference? What are the differences between lvalue reference and rvalue reference? Both lvalue reference and rvalue reference refers to another object. An object in C++ has memory and lifetime. Function also has its own memory. I am not talking about the memory stack, but once functions are created at compile time, they exist until the program is terminated. That is, functions also have their own respective memories. They do not have lifetime, for they exist all through the program runtime. So they are not called object. Once again, both lvalue reference and rvalue reference references to another object that has lifetime or object. What is the difference between lvalue reference and rvalue reference? Lvalue reference does not have its own lifetime. rvalue reference does have lifetime and has ownership of the object that it references to. When an lvalue reference goes off its block, the object that the reference refers to still exists in memory, but when an rvalue reference goes off its block, the object that it references to deceases or die or destroyed. Deceases, dies, or destroys. In a word, rvalue reference owns the ownership of the object it references to. When an lvalue reference goes off its block, the object that the reference refers to still exists, still survives in memory. For more information about std forward, please refer to All About std forward, this video. If you want to understand how to implement std forward, also non-deduced context, please refer to this video. In this video, I explained about how to implement std forward in 2 hours and 22 minutes. I gave all the gory details how to implement std forward itself. Also, about the C++ object ownership, lifetime, move semantic, please refer to this video. In this video, I explained object ownership and lifetime in gory detail. Without further ado, let's get started. Start Visual Studio Code, open CPP20, your working folder, select empty space, click this button, 075, decltype auto. Click this button, declauto.cpp, hit enter, Ctrl V, include talkplay fun, output HPP, namespace, types, talkplay fun, types, talkplay fun, stream, stream, auto, lvalue reference, NL, talkplay fun, NL, copy once, paste, NL, NL, void, understand, auto, reference, int main, copy the function name, paste it here. Before we further proceed, I will define some terminology. Template, type name T, void my function T, arg. T is template parameter. This T, arg, is called function parameter variable. Now here the type of T template parameter is different from that of arg function parameter variable. Suppose the type of arg is int rvalue reference. What will be the type of T template parameter T? I copy this. The type of arg is integer rvalue reference. Then this function parameter declaration here, the type of arg int rvalue reference arg. So if you are not blind, you can readily see it. T should be int or integer rvalue reference or integer rvalue reference, etc. I prefer integer rvalue reference for the type of T when arg, this parameter variable, is integer rvalue reference. But the C++ compiler selects int over integer rvalue reference. Now, if the type of arg is int reference, what will be the type of T template parameter? Once again, I copy this, paste it here, integer reference arg. By reference collapsing rule, t should be integer reference. Then 2 ampersand arg into reference arg. I will arrange the equal sign. Here int reference arg, it collapse int reference arg. Thanks to reference collapsing rule. The conclusion is that the type of template parameter t can never be rvalue reference, e.g. int rvalue reference. If you are doubt, stream the type of t, talk, play, fun, get type name t and l, copy paste the type of arg, get type category arg, void test template parameter and function parameter variable. Copy the function name, copy, paste it here. We will disable it here. The function name is my function. Paste it here. 5. I will put L int a, my function a. In the command prompt, dir cd 075 decltype auto clang cd c++ 17 declauto.cpp ltbb oc.exe, hit enter. clsc, copy this, cut, paste it here. We rebuild clsc 5 with rvalue. The type of t is int, as I explained. The type of arg is integer rvalue reference. When argument a is lvalue, the type of t is integer lvalue reference. The type of arg is integer reference. t can never be rvalue reference. Don't forget this. The conclusion is that the type of template parameter t can never ever be rvalue reference. Keep this point in mind. We will use this fact shortly. I originally planned to discuss auto reference, auto rvalue reference, but this episode is getting too long. Instead, I will revisit our previous program. Template, type name, t, type name, s, type name, arg, types, decltype, auto, sum, t, forwarding reference t, s, forwarding reference s, arg, types, forwarding reference arg's parameter pack. Now we classify with respect to parameter pack args. If context pair size of args is 0, else in this case size of args is not 0. Okay? here auto s sum t s. We are calling this function recursively. Then sum s, I would say t. No. Partial sum. This partial sum is here. args. We have to expand. Return. But this is not good enough. We want to recycle this value. So we use std move. Also std forward arg types. Also here std forward t std forward s. We have to fix like this. This is recursion. Using this partial sum, we form a new recursion. Now we collapse this part. Here, if context pair std is rvalue reference t, it should be v. We cannot use t because if we scroll up, the conclusion is that the type of template parameter t, this t can never be rvalue reference. I explained here. We have to test against function parameter variable arg. Scroll down. So we have to test against function parameter variable t, function parameter variable s, not the template parameter t, not the template parameter s. So decltype t like this. Else if context pair std is rvalue reference decltype s. Else auto r t plus s return r. Here t plus equal s return std move t. We tested t is rvalue reference. Because t is rvalue reference, we recycle rvalue reference t. T is named. T is named as function parameter variable. So t is lvalue. Do not confuse rvalue with rvalue reference or lvalue with lvalue reference. T is named as a function parameter variable here. So t is lvalue. To return lvalue as rvalue reference, we use std move or std forward. It's the same in this case. In the same manner, s is rvalue reference, we recycle s like this. S plus t. Return std forward s. In this particular case, this is equivalent to std move. Now everything is done. Here string the address of t, and then here string the address of s, ampersand s. Copy this, scroll down, right after r, the address of R, scroll down. I coded like this to explain recursion, but we don't need this. I will disable it, copy, paste it here. You now understand the recursion. Here, void test optimized sum int a equal 1, b 2, c 3, d 4, e 5, f 6, g 7, h 8, I 9, j 10. 10 integers. Auto x sum a, B, C, D, E, F, G, H, I, J. I will copy this, copy, paste it here. Address of x, stream, x, the sum of 1 plus 10 equals x and L. Copy this function name, paste it in function main. Now start Microsoft compiler, CLS. We build again, CLS M. So the sum is 55. First, the address of R, this address 550. The address of T 5E0. The address of X 6A0. So R is created once and copied to internal memory, that is the address of T. Then at this point the internal memory is copied to X. Let's try O2 optimization switch, CLS M. The result is 55. It's the same. Now we are using clang compiler. Hit enter. CLSC. The result is 55. R is created once, then copied to internal memory. That internal memory is the address of T. So the internal memory is recycled. Finally copied to X. The behavior is the same to that of Microsoft compiler. Now we give optimization switch O2. Hit enter. CLSC. The result is the same. Now GNU compiler G, hit enter. CLSG. The result is correct. R is created once here, then copied to internal memory. That internal memory is the address of T. So this is T. Then finally copied to X. The result is 55. Now we give O2 optimization switch, CLSG. Now watch it carefully. The result is 45. It's wrong. R is the internal memory. Internal memory is copied, but the result is wrong. So optimization switch can give wrong result. Without optimization switch gives correct result. With the optimization switch O2, the result is wrong. In case of GNU compiler, optimization switch failed. Let's try with SQL, Intel 1 API, dir cd 075 decltype 오로 dpcpp q std c++17 decl 오로 .cpp o d.exe without optimization switch clsd. The value, the address of R is 70C. So the value of R is copied to T internal memory. Then the result is copied to X. The result is 55, correct. Now with the optimization switch O2 CLSD. In case of Intel compiler with the optimization switch failed. Let's try with the optimization switch O3. Hit enter. CLSD with the optimization switch O3. In case of Intel One API tool, it works correctly. Please notice the address of R is 6E4, the address of X is 6E4. So R and X is the same variable. In case of GNU G++ compiler, with the optimization switch O1, CLSG gives correct result. With the optimization switch O2, CLSG gives wrong result. With the optimization switch O3, CLSG also gives wrong result.